Gonna go into depth on some of the 3D stuff, but just so you know, when we are talking about 3 dimensions, it's basically you have your flat, like say here's my flat, this is 2-dimensional, 2 dimensions, oops, which we, a lot of times, oops, I can't spell, dimensions, which usually we, in formulas we talk about as the base and the height, okay? The base being the bottom number, the height being this one, okay? We're gonna kind of change that up when we use formulas. Now when we add the 3rd dimension, the 3rd dimension is gonna be the height. So our 3rd dimension adds something that sticks out like this, okay? So now it's no longer just flat, okay? This flat 2-dimensional thing is actually called a plane, okay? The flat 2-dimension, boy, okay, I think that's spelled right. Anyway, that is a plane, okay? So when we get to 3 dimensions, we are actually talking about planes, 2 planes that intersect, okay? So when we get to 3 dimensions, is basically 2 planes intersecting. So I might draw, it's harder to draw 3 dimensions on a, I'll draw kind of a cube-like thing. Okay, so that's 3 dimensions. You have to, so drawing 3 dimensions on 2 dimensions is hard. It really is hard. And they use, we try to use it with dotted lines, like you won't see this to give you dimensions. We try to use the angles to try to make you see so that you don't see it. Sometimes they use graph or coloring or shading to show 3 dimensions, but it really is hard for artists. When artists are drawing things, it's hard for them to get the 3 dimensions in there, okay? Because they're doing it on a 2-dimensional piece, and to get that third, so it looks like that 3rd dimension is there, they have to sometimes use angles to cause that, or they have to use some sort of coloring or shading in there. And sometimes what they do a lot of shading with a little bit different color behind it, and that gives it the impression that there's a 3D picture there, okay? So it's a struggle for artists to do that, and they have to learn that if they're going to make it look like real life, okay? When we do 3D models and stuff, those really are 3-dimensional, so they're not as hard to make it look realistic, okay? Because you are doing it as a 3D object, and that's not as hard. So people that do things in art that are like ceramics and stuff like that, those are in 3D. Or if you do stuff with metal, a lot of people do metal art, and that is usually in 3D. Some people do 2D with metal, but it's a little bit harder to get that dimensional thing. Most of the 3D that I like of metal is when they have like the trees and they're kind of set different ways away around each other, or they have a mountain and trees in front, and there's just a little bit of space to give that 3D look, okay? So that's something that they use. There's also people that, of course, use 3D printers to create something that is an object that looks like something in the real world, okay? And so that's another way that we can use art. It's a different method. It's not quite the same way of doing art, but you have to program it unless you're using pre-programmed things. If you want a unique design, you have to program it to get it to make what you want, okay? So that's kind of what we want to look about. Now, lines, where are the dimensions? So we're 2 dimensions. or where two planes meet is, so look at the wall and the floor. See the two dimensions meeting? We have two planes. The wall is one plane, the floor is another plane. What is it where they meet? What do you see?
An angle?
It is an angle, but what is the basic thing that they have there?
A line?
A line. Okay, there's a line where they meet. So where two planes meet is a line. Okay, that line, in most of our stuff, not in everything, but in most of our building, that line or that plane is what to the other plane? Now think about that angle.
Oh, perpendicular.
It's perpendicular. So in most building, the two planes which would be, I may call it the wall and the floor, are perpendicular. Okay, so that's really what that's saying. It's just saying that most of the time we build things at a perpendicular. It causes all sorts of problems if you don't get it perpendicular, because it really gets problems if you start building a house and it's not perpendicular on one wall. Okay, so yeah, it's a slanted house.
Parallel house.
The other thing is, excuse me, two planes are parallel if they never intersect. So here I say, think about two different walls. That wall is parallel to this wall because they are not going to intersect. If you go on that wall there, it's never going to intersect with this wall. Okay, so they're parallel planes. Okay, if you had them just a little bit difference apart, you know, they would meet somewhere, they would eventually meet and cross. So if they're not exactly parallel, they will somewhere meet down there. Okay, so they will intersect. Again, all planes, when two of them meet, it's always a line that you get. Okay. So that's really the main things I want. There's a few other words in there, but I'm not going to go over those with you because I don't think it's really that important for you to know those. Really, I just want you to know they're called planes. That's what technically it's called, and that they intersect at a line that most of the time our planes intersect perpendicularly in the real world, and they're parallel if they don't ever intersect, which kind of makes sense. It's all kind of like lines. It's really very similar to lines, but now instead of just a single line, you have basically pieces of paper that you're putting together. That's one way of thinking about it, or walls that you're putting together. Okay.
The doors and the windows are straight, but not the not the circumcision.
Okay.
Can't because it's a parallel.
So the next thing we're going to go into, which we talked about last year, and probably the year before.
Was that 15-1?
That was 15-1. Yes,
Okay,
that was
so not two.
15-1. Well, this is 15-2 now. We're doing rectangular solids. Okay. I think it's funny we call them solids because they're not necessarily solid. Okay. So what we're talking about is we look at, we can have planes that meet together. One of the most basic plane that meets together, yeah, not like in Washington, D.C., where they met and they weren't supposed to meet. We don't want that, okay? So anyway, a rectangular solid is made of all rectangular planes. Okay, so basically it's like a box. okay? That's why I think it's funny they call it a solid, but we can think of solids that are also rectangular. Think of a brick. A brick is a rectangular solid because it has all rectangles on it, okay? Some of our building materials are rectangular solids. If you think of plywood, it is a rectangular solid. It's just got a very
So
thin height, but it is a rectangular solid, okay?
Super air.
So anything that has rectangles, either on the sides, fronts, or backs, is called a rectangular solid, okay? When you're looking at rectangular solids, we need to talk about, well, we're putting in some of the things. Again, I'm going to
So you draw a G.
draw one.
Brick with
Yep.
another brick.
Yeah.
It's my rectangle card. It's my G. I'll show you mine.
Okay, so this is my attempt. I'm sure some of you guys are much better
Or much worse.
Yeah.
at drawing a rectangular solid. Or you could be worse, it's okay. I could never draw them at all until my daughter said, just make one rectangle and then make the same rectangle down here. And that will help you to put them together. They still don't look great, but my daughter's the artist, so she's very good. She can give all that perspective and stuff very well when she does stuff. Maybe I should bring in one of her charcoal paintings to show the 3D in it that she got. Those are very pretty.
Rectangular solid.
Okay, so some words that
This
go
one.
along with pretty much any polygonal solid, okay? So solids can be made up of any type of polygon. We're talking specifically right now just about the ones that are made up of rectangles, so that's why they're called the rectangular. Just a minute, I have to, there's something about updating, I didn't want it to update. Oh, no.
Whenever Steven starts
No.
like, I want to update, you're like, no.
I said, remind me tomorrow, please
Yeah,
just let
exactly.
me remind. Oh,
So bad.
jeez,
Steven's
Still
still
running Windows 9 on my computer. in 2020.
tomorrow.
Bro, I
Sure.
tried to make rectangular solid and it
It
worked.
It worked.
It has problems. It's more aerodynamic.
Okay, I'm
The
sure this is
windshield is
beautiful.
really
You
like
get me
this.
staring with my face and my mouth open right there for that part, but anyway. Okay, so when we're looking at any of these, where the point where three solids meet or three planes meet right there on a rectangular solid is called the vertex. Seems like that's used for so many things. We use it for parabolas. It's really just a point that there's a change in direction. That's pretty much what vertexes are. So how many vertices are in a rectangular solid? If you were to look at a box, how many vertices would there be?
8.
Well, there'd be 1, 2, 3, 4, 5, 6, 7, 8. Okay. We'll use this even though it's not perfectly a rectangular solid, but it's handy. Okay. On this, usually we locate these and we talk about this as we'll talk about this as the length, the width, and the height. That's normally how we talk about a rectangular solid. Now, the height is very important because it's that third dimension. Okay, so we go back to length and width here as far as what the things we're looking at. Okay. Where these two planes meet, so the two pieces of paper meet there at the corner, it's a line. That line is called an edge. Okay, so that's the line where two planes meet. this is the point where 3 planes intersect. Okay. And then we call the planes, each plane, each rectangular plane that you have there is called the face. So like this rectangle is the face. So that's the rectangular plane. Okay, so those are the things that we have that we name on, so they'll talk to you about how many edges, so just so you know, vertex is a point, okay, because remember I said there are points, we can have points, okay. A edge is a line, okay, so it's a line, and a face is a plane. It's like a flat piece of paper or a flat surface that you have, okay. So that's what we're looking at. When we get into other solids, we will also be looking at their edges, their faces, and their vertices. Okay. So that's one of the things we do. Okay. In this, when we have a rectangular solid, opposite vertices are not the same as what they used to be when we were talking about quadrilaterals on a flat piece of paper, okay? So opposite vertices are basically the line, or the vertices, I cannot spell, oh my gosh. Vertices that, I better see how they write it, that are not on, they're not of the same, vertices that are not on the same phase. Okay, so if I took this one that's back there, okay, if I came over to here just directly, that's on the face, right? That's on the bottom, and so that's not an opposite vertex. But if I went from here to this one, you're going from the back of the box up to the front of the box at a diagonal, basically, okay? And so that's what you can form is diagonals of this. So diagonals are lines from or between opposite vertices. Okay, so how many diagonals does this figure have? How many of them are there? There are 4. That's correct. Okay, does everybody see 4? Let's start. Bottom up to the opposite corner. 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 So there are 4 of them. And the easiest way for me is to always start at the bottom and go to the opposite corner so it's easier for me to see them. Okay. What do you guess about those? What do you guess about those diagonals?
They're all equal.
They're all equal. Yes, the diagonals, all 4 diagonals are equal. Okay. Now, we could calculate it, but it'd be kind of confusing how to calculate it across. You'd have to first get the length of this side, and you can do a right triangle to get the length of that diagonal. But there's actually a formula that you can use for all rectangular solids to get the length of all 4 diagonals. So the length of a diagonal in a rectangular solid, I'm not saying this works for all, this works for rectangular solids, is the diagonal, I can't remember if this is squared, I have to always remember. Yeah, it is squared, okay. The diagonal squared is equal to the length squared plus the width squared plus the height squared. That's what it ends up being, is that if you are looking at the diagonal and you want to find the length of it, there's a relationship. It's kind of like the Pythagorean theorem, but because we have 3 dimensions, it has 3 things that are put into it. All 3 dimensions are put into it. And then once you get that, you can take the square root. It's actually technically the square root, but this is the formula that you can use. Okay. So that's basically what you're coming up with.
Dimensional bulk.
Seeing if I covered everything. Diagonal dimensions, length, width, height. They do give you one thing, is that if you have a cube, which just kind of makes sense, I'll show you. Oh, well, okay, you get the idea. There's my cube, okay? Which means the length equals the width equals the height, correct? Okay, so the diagonal in this is going to be d squared equals, I can use one of these. I'm going to use height because they're all the same, right? So I'm going to use height squared plus height squared plus height squared. So the diagonal squared is equal to 3h squared. If I take the square root of both sides, I get d equals square root of 3 times the height. So in a cube, if I know one dimension of it, take the square root of 3 times that, and it will give you actually the distance. So this is the length of a diagonal in a cube. And you don't have to say height, you can substitute in here width or length, because all of them are the same, right? A cube, all of them are the same. So that's all we have to know on that. Okay. So that's basically all we're going to go through. Now we're going to look at some pictures which are kind of interesting for dimensions, to see if we can see on the flat surface what the dimensions are. So I'm going to turn this off, and we are going to